Hello dear students, this is Mr. Hitesh Patel, Assistant Professor LJ Institute of Engineering and Technology. In this video series, we will discuss a subject Basic Mechanical Engineering. Today in this video series, we will discuss about the air chamber, double acting reciprocating pump and basics of centrifugal pump. So let's start. So this is the figure of air chamber. First of all, what is the function of air chamber? So air chambers are mainly used for three purposes. The first is to obtain continuous supply of the liquid. That problem will arise in single acting reciprocating pump. In single acting reciprocating pump, we are not able to get continuous supply of the liquid. We get intermittent flow during the operation. Okay. The second one is to save considerable amount of work, and third advantage by using air chamber or air vessel, that is to run the pump at high speed without cavitation and separation. Okay. So these all are the advantage of air chamber. So how we will get these advantages by using air vessel? So that we will discuss. So first of all, you can see that near the suction valve there is air vessel is fitted, and near the end of the delivery valve, after that delivery valve, the air vessel is fitted. Air vessel is a simple arrangement in which the air is there. Normal atmospheric air is there, and air vessel is fitted on the suction side as well as delivery side. On suction side, it is fitted before the suction line or before the suction valve, and at the end on the discharge side will be fitted after the delivery valve. Okay. So whenever the crank travels from 0 to 180, at that time piston will travels from left to right, and due to that a negative pressure is generated and suction of liquid takes place, and cylindrical whole cylinder is filled with the liquid. But when the suction of the liquid takes place, at that time some amount of liquid will enter inside the air vessel and fills the air vessel with water. But we know that inside the air vessel there is air, so that the air which is compressed at the top portion of the air vessel. Okay. And at the end of the suction stroke, the piston is at the end of this one end of the cylinder, and both the suction valve and delivery valve will remain closed. Okay. Now during next stroke, the crank travels from 180 to 0, piston travels from right to left. Due to that, a positive pressure is generated inside the cylinder, and suction valve will remain closed, delivery valve will remain open, and discharge of liquid takes place to the discharge tank through discharge pipe. But during discharge, there is an air vessel which is fitted. So due to that, some amount of liquid or water enter inside the air vessel B. Okay, and the air is compressed at the top of the air vessel. Again during the next stroke, the piston travels from left to right. During this stroke, due to negative pressure, the suction valve will remain open and delivery valve will remain closed. As the suction valve will remains open, due to that the air which is at compressed condition compresses the liquid to comes out through the air vessel, and that liquid will directly available at the end of the suction valve. If there is no air chamber is installed, then the pump has to make a effort of suck the liquid from the sump. But here the liquid is available at the doorstep because of the air vessel, so the pump work will be reduced. So the second advantage is considerable amount of work is reduced. If the liquid is not available at the doorstep, then the pump has to work more. Due to that, there is suction of the liquid takes place. Due to that, negative pressure is generated. So at some time, during some time, the small bubbles are formed. Okay, and due to that, the cavitation problem will be arise inside the pump, and it can damage the inside wall of the pump or inside surface finish of the pump. Okay. So by using air vessels, these all are the advantages, and the third advantage, the first advantage is it will supply the continuous supply of the liquid. So during suction stroke, when there is suction stroke performed, at that time the compressed air compresses the liquid to continuously flow into the discharge tank. So whenever here suction stroke is performed, at that time the air vessel, the air which is at the top of the vessel compress the liquid to the discharge tank. So by this way we can get continuous supply of the liquid. So these all are the advantages of the using air vessel in single acting reciprocating pump. Next topic is double acting reciprocating pump. In single acting reciprocating pump, we know that there is only one suction pipe with one suction valve, one delivery pipe with one delivery valve is fitted. But in double acting reciprocating pump, there are two suction pipe with two suction valve SA and SB. Two delivery valve DA and DB are used. Okay. So there are two suction pipe with two suction valve, two delivery pipe with two delivery valve, one piston, cylinder, connecting rod and cranks are used. There are two stroke in this type of pump. The first one is forward stroke and second one is reverse stroke. So let's discuss the forward stroke. During forward stroke, the crank travels from 0 to 180. As the crank travels from 0 to 180, piston travels from left to right. Due to that, negative pressure is generated on the left side of the cylinder and a positive pressure is generated on the right side of the cylinder. So due to negative pressure, the suction valve SA will remains open, delivery valve DA will remains closed, and due to that suction of liquid takes place from the suction pipe A to the cylinder, or we can say that on the left side of the cylinder. At the same moment, the liquid which is stored on the right side of the piston during previous stroke gets compressed, and due to positive pressure the suction valve SB will remains closed and delivery valve DB will remains open, and discharge of liquid takes place to the discharge pipe. Okay. So this is all about the forward stroke. The second one is reverse stroke. During reverse stroke, the piston travels from right to left. As the piston travels from right to left, the negative pressure is generated on the right side of the piston and positive pressure is generated on the left side of the piston. Due to negative pressure, the suction valve SB will remains open, delivery valve DB will remains closed, and suction valve SA will remains closed, delivery valve DA will remains open. Okay. So the suction of liquid takes place from the suction pipe B to the right side of the cylinder, and there is a discharge of liquid takes place on the left side of the cylinder as positive pressure is generated on the left side of the piston. Okay. So this is all about the double acting reciprocating pump. In double acting reciprocating pump, we will get continuous supply of liquid as the both side of the piston are covered with the liquid, so it is known as double acting, and the piston is reciprocate, so it is known as reciprocating pump, and in each stroke we will get the discharge, so we will get continuous supply of the liquid. So next is centrifugal pump. In centrifugal pump, we can see that there is an impeller which is surrounded by casing. There is a delivery pipe with delivery valve, suction pipe, foot valve and strainer is installed. So these all are the components of centrifugal pump. So how the centrifugal pump work, or on which principle centrifugal pump work? So if the mechanical energy is converted into pressure energy of the pump by means of centrifugal force acting on the liquid for conveying the liquid from one place to another place, such type of pump is known as centrifugal pump. Okay. So centrifugal pump, when the impeller in centrifugal pump, when the impeller is rotated, due to that negative pressure is generated inside the casing. Due to negative pressure, there is a suction of liquid takes place from the suction pipe to the pump. When the liquid comes out through the suction pipe and entering inside the pump, due to rotating impeller, the liquid comes in contact with the rotating impeller, and due to that rotating impeller, the liquid gets kinetic energy, and with high kinetic energy, liquid leaves the impeller. And as the liquid leaving the impeller, due to, you can see that there is a gradually increasing in area between the impeller and casing, there is a conversion of kinetic energy into pressure energy takes place, and with high pressure energy liquid gets discharged. So this is the basic working of centrifugal pump. Let's discuss each and every component or parts of the centrifugal pump. So the first part is impeller. So as we have discussed that the impeller is rotating part of the centrifugal pump and it increases the kinetic energy of the liquid. The second one is casing. Casing is an airtight passage which surrounds the impeller, and the casing is converted into kinetic energy of the liquid discharge into pressure and energy before leaving the delivery pipe. The next is casing. Casing is an airtight passage which surrounds the impeller and it converts the kinetic energy of the liquid which leaves the impeller and converted into pressure energy of the liquid before the delivery pipe. Okay. The third one is foot valve. So foot valve is a non-return valve which is fitted at the end of the suction pipe. Okay. It is always deep inside the water and it is used to prevent the backflow of the liquid from the suction pipe to the sump. Okay. The fourth one is strainer. So strainer is one type of filter which is used to filter the incoming water into the suction pipe and remove all the impurities from the water so that there is no problem of the choking of the pump during the operation. The fifth one is suction pipe and the sixth one is delivery pipe. We know the function of the suction pipe. So it supplies the liquid from the sump to the cylinder when negative pressure is generated. And the sixth one is delivery pipe. So it discharges the liquid from the pump to the discharge tank. Now, what is priming? So priming is necessary during the operation of centrifugal pump, because in centrifugal pump whenever we stop the pump at that time it remove all the liquid in it. So during the next operation again it creates necessary amount of vacuum and after then it will suck the liquid and then the discharge of the liquid takes place. So priming means the process of filling suction pipe, casing and discharge pipe up to the discharge valve with the liquid before starting the pump. It is necessary because without priming the centrifugal pump will not able to discharge the liquid because density of air is very low and density of air is high. So there is a problem while there is air present inside the pump of the suction. So when the impeller is rotated, the centrifugal force is produced and due to this force the water is enter inside the impeller and due to the rotation of the impeller the incoming water transfer into the casing and where its kinetic energy is converted into pressure energy and liquid will be discharged. Okay. So this is the basic operation, but reciprocating pump is a self-priming pump, but centrifugal pump requires priming because reciprocating pump generate automatically the necessary amount of vacuum for the next operation. But centrifugal pump will discharge all the liquid and during next operation again we need to prime the centrifugal pump. Okay, so that's why the reciprocating pumps are self-priming pump, but uh, centrifugal pumps requires priming. So this is all about the priming. There are total four method for the priming. The first one is manually priming. The second one is priming with a vacuum pump or reciprocating pump. The third one is priming with jet pump and the fourth one is priming with air separator. Okay. So let's discuss the difference between reciprocating pump and centrifugal pump. So the first difference is the reciprocating pump works on the principle of positive displacement and centrifugal pump works on the principle of rotodynamic. Second is the discharge is fluctuating, okay, and pulsating in case of reciprocating pump, but the discharge is continuous and smooth in case of centrifugal pump. The it can produce high head but low discharge, but centrifugal pump produces low head with high discharge. Initial and maintenance cost is very high in case of reciprocating pump, and initial and maintenance cost is less in case of centrifugal pump. Reciprocating pump runs at very low speed, centrifugal pump runs at very high speed. The efficiency of reciprocating pump is low, efficiency of centrifugal pump is high. Reciprocating pump produces much noise. The centrifugal pump smooth operation done in case of centrifugal pump without any kind of noise. So this is the basic difference between reciprocating pump and centrifugal pump. If you have any query in today's topics, then you can write down your comments in the comment section. I will be happy to solve your queries. Thank you for watching my video.